Okay, integration from 0 to 1, e to the power of 1 over x cubed dx. Now this is still an improper integral because of the fact that we're starting from 0. When you actually plug in 0, right, it's undefined. You can't divide by 0. Okay, so that's why it's an improper integral. Okay, so let's first think about how to integrate this, how to find the antiderivative of this. Now, note that we have a 1 over x on the top here, and if we differentiate, we almost get, right, what we have on the bottom. So let's first remind ourselves, when you differentiate this, you get 1 over minus 1 over x squared. Okay, so let me just write that in terms of u. If u is equal to 1 over x, then du is equal to minus 1 over x squared dx. But I have a little bit more than that. But if I separate, okay, so 1 over x times by, at the back, 1 over x squared dx. Okay, so the two of them, if you multiply them together, we get this. And then I'm going to write this in the middle here, 1 over x. Okay, you can see that right there can be replaced with minus du. So I'm going to write minus du. And this is another u. So we have a u e to the power of u. Okay, 0. Okay, you know what? We have 0 to 1, but now it's in terms of u. Okay, in terms of u. So 0 to 1 in terms of u now. Right, it's going to be undefined. Right, undefined. 2, 1. Right, 2, 1. Okay, so let me write that here. Undefined 2, 1. Okay, so let's actually flip this. Let's switch the order from 1 to infinity. Multiply by negative 1, and that'll become positive. You have u e to the power of u du. Okay, now this right here is an integration by parts. Okay, so let's continue by integration, using integration by parts. Okay, let's let a equal to u and db equal to e to the power of u du. So we get dA is equal to du, and b is equal to e to the power of, okay, e to the power of u. So this, by integration by parts, is u e to the power of u minus the integral of e to the power of u, which is going to be u, right, e to the power of u minus e to the power of u. Okay, and we got to insert 1 to infinity, but I'm going to write that as t, and we're going to take the limit as t approaches to infinity. Take the limit of that. Okay, first get this expression in terms of t, and we get t e to the power of t minus e to the power of t. Plug in 1, and you get e, right, e to the power of 1 minus e to the power of 1 again. So that's going to go away. Right, that's going to go away. So we just have a limit as t approaches to infinity, right? T, we can actually factor out e to the power of t, e to the power of t, t minus 1, right? And since both this and this is approaching infinity as t approaches infinity, we said this is diverging. Okay, it's diverging.